Welcome back to Just Code It. Today we're going to be creating an app. This app is a legal document analyzer. It allows you to upload a legal document. Then it analyzes it, giving it a summary, risks, suggestions, and then a full report that you're able to download. How the app works is you upload a PDF that is a legal document, and then you click Analyze. It extracts Markdown from the PDF and then feeds it into a large language model, where the large language model produces a document summary, risks within the document, suggestions for how to improve the document, and then a full report that you can download. This app uses LangGraph for the workflow, LangChain for the LLM framework, and PyMu PDF for the PDF to Markdown converter. It's actually pretty good. I was using Dockling before, but it was extremely slow. This is way faster than Dockling and good enough. In the future, we're gonna expand this app. I'm actually working on this more on a command line for work, so I decided to port it over to do a YouTube video for it. What we're gonna do is expand this so that it is giving really detailed suggestions, risks, and summaries, and then edits the document with comments on where to improve. The app is able to upload PDFs as well as text files, but most of the time you're probably gonna use PDFs. Let's get started on actually coding this thing. To start out, we're gonna load our environment variables and set up a few default variables. We're going to do a default model, summary temp, risk temp, and suggestion temp. I kept these separate just in case I wanted to fiddle with them later on. I just have a default model here and I'm using it throughout the whole code, but I believe this would work a lot better if you use specific models for each individual section. Going forward in part 2, we'll probably extend this and use different models for each one. After that, we're gonna set the defaults for the state variables with all those defaults. After we get that set up, we're actually gonna jump to the bottom to the main method. What the main method does is essentially the event loop where it's rendering all the components on the Streamlit app and analyzing the document when the button is pressed. Now that we have the main method all set up, as we start filling these out, this will populate with each component and functionality. Moving back up to the top again, let's start with the agent state. The agent state has a few variables within it. It has the original text, summary, risk, suggestions, and then the final report. After creating the session state, we're then going to come down here and create this little hashing function, the file hash, which is used to create a unique hash to identify the uploaded file so we can cache it. This prevents redundant processes where we would have to reprocess the file each time. We use the hash library and SHA-256 pass the data, and then hex digest and just return that. We're also going to cache the LLM as a resource. We're returning the chat with the model, base URL, and temperature of it. Now that we have the get LLM, we're gonna do the call ollama, where we're gonna do LLM.getLLM, and we're gonna get that cached.LLM. Then we're gonna invoke the prompt. After getting the response, we're going to return the stripped content of the response or an empty string. Moving down to the AI agent nodes. The first agent node we're going to work on is the summarize node. A lot of these nodes are going to be the prompt, but the prompt is pretty important for this application. We're going to pass in the state, create our prompt. Our prompt is going to be the original text, and then we're going to have some information about how we want to summarize it and pass it the document text. Finally, we're going to return the call LLM, pass it the prompt, pass it the model, URL, and the temperature, and set that equal to the summary within the LangGraph agent state. We're going to essentially do the exact same thing for the other two. Analyze, we're going to create a prompt, give it the text that it needs for the prompt, then pass it the LLM with the prompt, model, blah, 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 and return this updated state. Moving down a bit more, we have the improve. Again, another prompt, asking how we can improve this, and then give it the text. Suggestions, call LLM, and the same as before. I decided to do it this way so we can easily swap out the model and the temperature in the future instead of just hard coding it in here. The last node we have is compiling the final report. In the state, summary is, and suggestion, and formatting it all together, returning it as the final report. Next up, we have creating our LangGraph workflow. State the graph, and then give it our initial state that we created above. Set it equal to our workflow, add all of our nodes. This is the graph we're creating. It's just a linear graph. You could have done this in LangChain. I'm doing it in LangGraph because if you want to extend it later on and actually create a more dynamic agent, it's a lot easier to convert from a LangChain, a LangGraph chain, than a LangChain to a LangGraph. So that's what we're doing, but this is the graph that we're creating: summarize, analyze, suggest, and improve. One interesting thing you can try out is to actually run these in parallel. One thing we will do in the upcoming videos is convert this into running in parallel to make the performance a lot better. We'll run the summarize, analyze, and suggest all in parallel and compile the final report at the end. Currently, we're just having them in series. Entry point is summarize to analyze to suggest to compile report to end. We compile the workflow and return the graph. We're also caching this as a resource. The next two methods we have are load doc and analyze doc. The load doc method first gets the suffix and the data from the document, then looks to see if it's a text file. If it's a text file, it will return the decoded UTF-8 data. Otherwise, it creates a temporary file. What this does is creates a temporary file on the desktop and writes the file, then grabs the path from the temporary file. After we have that temporary file, we use this PyMu PDF for LLM. They really need to change that package name. That's horrible. To Markdown and pass it the temp path. After getting the text from the PDF, we then move on to deleting that temp file and returning the stripped text. After loading the doc, we analyze the doc. How we do this is get the workflow from the previous method, then we do app.invoke and pass it our initial state, which is the original text and the doc text. That is it for the LangGraph components. Now we're working on the Streamlit components. We're going to render the sidebar first. The sidebar has a header and then a file uploader right here. With the upload, we pass it the types, PDF or text, add a divider, and then add the information for the model. We're grabbing the default model and then a text input. If someone sets this, we're going to overwrite the session state model name, which will change it throughout the application. Finally, we return the results of the file uploader. The analyze uploaded file method first creates a progress, which is reading document, and then uses a previous method to load the document. After it gets the document text, it then splits that document text and creates a preview. Then we have another progress bar with a value of 50 that says running analysis, which creates a result given the analyze doc. We create another progress bar for the analyze doc method where we pass it the doc text and get the results. Finally, we set the session state result by hash, where we pass that hashed file and we set that hashed file value to the result. This is how we create that key where each individual file has a specific result and we won't duplicate. The last method we have is display analysis. This creates the 4 tabs right here, and it sets the text within those tabs using the ST markdown. It gets the summary or get empty list if there's nothing there, and does that all the way down the row. Finally, the last thing we add is this download button. Let's actually add this download button up here. Yeah, that doesn't look great, but it's better than scrolling all the way to the bottom. Now we have the tabs underneath the download button, and then if you click the download, it downloads a legal analysis markdown file. Moving down a bit more, we have our main method where we just create our page config, set our default values, create our sidebar, upload our file. If the file is uploaded, we then create a hash, set the default hash. After we create this default results by hash dictionary, we wait for this analyze button to be pressed. Once that's done, if H is in the session state results by hash, display the results. If the hashed file is within this dictionary, we display that hashed result. The last thing we do is display a warning message if there is an issue with uploading the file. Now that we're done with the app, let's use it to its full extent, where we're going to upload an actual legal document and see how it analyzes it. Here we have a lease agreement, 3-page lease agreement. We're going to select that and click Analyze. Here we have the top part of it. It does take a while to process larger documents. In the future, we're gonna work on increasing the performance using parallel agents and maybe figuring out other methods of analyzing all this text at once. Maybe we'll use a vector database. I need to think about the best way to manage all this text. I'm also using a llama, which is not the best. If you used an actual inference provider, you can then use async await and get this going a lot faster. A llama is very linear and it only allows one request at a time. It does not allow batching. If you use something like VLLM or SGLang, you can batch and process multiple requests at a time, which is what the inference providers do for being able to handle multiple users. I wish a llama had that ability, but they do not yet. I'm still waiting on them to add that because that will be awesome once they do. Here is the full report. After it's done, you have all this. I found a lot. I think it started repeating. Let's try this with a larger model. I'll fast forward this, but I want to see how much better it is with a GPT OSS 20 bill. I love these GPT models because they're smart and good at formatting, but extremely fast. This one is equivalent to a 4 billion parameter model. It might be 4 to 8 billion parameter model is how fast this one is because of the mixture of experts. But yeah, you can see how using the bigger model really improves the results and it's not that much slower. It might make sense to use a bigger model if you have a GPU to run it on. Let me know if you have any ideas for what to add to this app to improve it. I'm creating this project to process legal documents for work, but if you have any ideas on how to improve it or want to give any feedback or want me to go into depth about something, please feel free to comment down below. Also, please like and subscribe. That really helps out the channel. I hope you enjoyed today's video and see you next time.